Progress.
Assist due to gravity. I think we have got a certain term. We have got a term here, and you may be confused this term assist due to gravity with the term universal gravitational constant. Right? Many of the students become confused because they too have got the same symbol. All right? Whenever we were talking about assist due to gravity, we write the symbol that the denotes. We denote acceleration due to gravity by small letter g. I remember this. Acceleration due to gravity denoted by small letter g, while the acceleration, sorry, the universal gravitational constant is denoted by capital letter G. And that's why we student become confused in small letter G and in capital letter G. The two are different things, right? The capital letter G and the small g are different to each other. Remember this, right? So what is mean by acceleration due to gravity? We'll know that. Before that, we have got some introduction, description about acceleration due to gravity. So, according to Newton's law, second law of motion, acceleration, right? We have read about acceleration in Newton's second law. Right? We have derived the formula. In the first law, we have got a definition that appeared in the universe tends to be in the state of rest of motion, okay, unless external force act on it. That was the first definition. In the second one, it has told that the acceleration is directly proportional to the force and inversely proportional to the what the mass of the body. And the third was action as the equivalent opposite reaction. Yeah, we'll talk about the second law, right, of Newton. According to Newton's second law of motion, acceleration produced in a body is directly proportional to the magnitude of net force. Again, the acceleration is directly proportional to force, right? Whenever the force increases, then the acceleration of a body also increases. For example, whenever you have to push a body, and at the time, if you apply more amount of force, that body will also produce more amount of acceleration, right? So acceleration depends upon the force, that has been told you by Newton's second law. Right? So yeah, I think you had about 10 examples, I think, in class 9. If you go to your class 9 book and look at your, there you have got about 19 examples, right, of Newton's law. If the force is applied, if the force is applied along the direction of motion, the object speeds up. Right? Thus, for example, the object is moving in right hand direction. Right? The object is moving in right hand direction. Then at that time, if that if you apply the force in the same direction, if you push the body in right direction, then that body will start to speed up. Right? Speed the body answer. It will increase simultaneously. Again, just for example, if the body is moving to, let us say, to the downward direction, then if you apply more amount of force, then that body will start to speed up. Right? You can see that whenever, again, if some vehicle will let us suppose be damaged, again if if we keep that vehicle in downward direction, that body will speed up, speed and that will move in a high speed. So that's why, the same thing is being told here. If the force is applied, then the object will speed up. And if the force is applied in opposite direction, then the object, the direction of the motion, it slows down. As for example, if the body is moving in right and you are starting to apply force from the left, body gets a right to move by rasa you will say left force then at that time that object will slow. That's why you sometimes you stop some object like that. Right? The object is coming from the forward direction and you apply the force. Right? Then the object will be stopped. Right? Now, when a body is dropped from a certain height field, right? Whenever we drop something, we have taken a body to a height malan, right? Let us suppose to fourth floor, fifth floor, right? It can be anything. It can be any height. We have taken that body to certain height. its velocity changes. Sorry, we are drought also, and its velocity changes increases as it descends downwards, and the velocity will start to change at as it will fall down. Right? So, के जो खस्दाखेरि velocity change हुँदै जान्छ. Look at it. When we are holding it in a hand, at that time it was 0 meter per second. Now we have left that. छोड़ दें हामीले अब. Look at that. After 1 second, the velocity of that body will change to 9.8 meter per second. And then again, after another 1 second, it will change to 19.6 meter per second. And similarly, at the third second, it will change to 29.4 meter per second. Now look at it. In the above figure, apple is drawn from a certain height. It's drawn from a certain height, that is A. At position A, velocity of the falling apple is 9.8 meter per second. It's not at A. Let us suppose at B. At B, the velocity of body is 9.8 meter per second. Similarly, in another 1 second, that is in C, it is changing to 19.6 meter per second. And this is true, right? This value is true for all the body, whatever be the mass. Mass could be 10 kg also, mass could be 100 kg also. For every kind of body, the value of this velocity while falling to the earth, the velocity value, it is always the same, that it is independent of the mass. But you may have seen that again the body having high mass will fall faster on the ground. I know जुन के भन्छ धेरै mass भएको हुन्छ त्यो चाहिँ छिटो खस्छ ground in their surface. That has got a separate reason for that. छुट्टै reason छ त्यसको लागि. Right? And we are going to experiment also for that. Yeah. Junior and Cohen and Feather experiment done by a scientist named Galileo Galilei. Right? So here we are talking this condition. This condition only arises. This value will only come when there is no air resistance. We are neglecting air resistance. We are neglecting air. We are supposing that there is no air in the earth. Right? There is no air in the earth, and at that time this value will come. Otherwise, the value may differ. The value may vary. Change. So now it has gone to D and it has changed 29.4 meter per second. So now the job here is to find the acceleration from A to B. Okay. Quickly find out the acceleration from A to B. I think you know the formula. What is the formula to find the acceleration of a body? Class 10. What is the formula to find the acceleration of a body?
V minus U upon T.
What?
V minus U upon T.
Okay, V minus U upon T. Okay, from A to B, right? That we are talking about A to B. What is the value of B to here? Sorry, B. Right, we are talking about B to B.
Yes, sir.
What the value of B while going from A to B? Final velocity.
9.8 meter per second.
Okay, B is 9.8 meter per second. Now, what is the value of U then? Initial velocity.
0.
0 meter per second. And value of T?
1 second.
1 second.
So, what will be the answer then? Acceleration.
9.8 meter per second.
What? 9.8 meter per second. Okay, thanks. And while going from B to C?
19.6 meter per second.
That's the final velocity, 19.6 meter per second. Now find out the acceleration by using this value. from B to C.
B to C.
Hmm.
B. T.
How much will be the acceleration? Right, take a calculator and do it in a calculator.
Initial velocity to सबैको 0 होला नि सर है?
Now we are taking from B to C, not from A to C. So the initial will be 9.8.
9.8 meter per second हुन्छ होला नि सर.
9.8 meter per second square, right? Acceleration, I have asked acceleration. The change in velocity is 9.8 meter per second. Change in velocity and acceleration is 9.8 meter per second square. Right? By 1 second, so the unit will change to meter per second square. Right? Very much of acceleration. Going from C to D now.
9.8.
9.8 meter per second square. Now, can you tell me if this apple, I think this is the apple, if this apple would have gone to E after 1 second, what will be its velocity? Arko 1 second पछि के हुन्छ its velocity त भन.
तर यिनी छैन त.
Why भने if there would be
39 point कति मिटर पर सेकेन्ड हुन्छ होला.
त्यो दुईटा बुढा बुढी
39 point.
Huh?
What, Krishna? What did you tell just now?
$39.2.
Okay, 39.2. And it is changing by 9.8. That means we'll have to add 9.8 more. It will change to 49.2 meter per second, right? So the velocity will changes by 9.8 meter per second in every 1 second, right? Har ek second ke huncha 9.8 meter per second le velocity change bhayirahko while a body is falling on the earth surface, and we call that change of velocity with time. Right? We call that let us say the ratio of change of velocity or the rate of change of velocity with time is acceleration due to gravity. So to write down here, x acceleration due to gravity is 9.8 meter per second. I'll write square like this, meter per second square. That is square, and mathematical form you'll write like that, right? Like that. That is exponential sign. What do you mean by the statement? So the question here. Now answer. While a body is falling on the or surface, its velocity changes by 9.8 meter per second meter per second in every 1 second. So acceleration due to gravity of a falling body is 9.8 meter per second square on the Earth surface, right? Okay. Write down this. Written.
Yes, sir.
Okay. Now, same like here. When a body is third paragraph, right? When a body is drawn from a certain height, its velocity changes due to effect of gravity. Okay. When a certain body is changing, when a certain body is falling, then its velocity will change, and the velocity of the body will change. How? Due to the gravity. It is all done due to gravity. If the gravity will not be there, then the velocity will not have changed. Obviously, the body won't fall on the Earth surface, right? If there would be no gravity. Gravity no आगे क्यों तो the body Earth has Earth है ना, and velocity even change होता है ना. There would be no acceleration due to gravity, right? This is the factor why the acceleration due to gravity occurs. Its value is the same on all the bodies on the Earth surface. I told that the same on every body. Right? Whatever be the mass, you have taken mass of 10 kg also, you have taken mass of 100 kg also. For everybody, the value is same for G. But the air resistance can change the falling bodies of lighter bodies. Again, but the air resistance can change. Again, you may have seen that. I will that the the heavier body will fall faster. And I don't got the cheetah faster. You know, because due to air resistance, like that, right? And what is the air resistance? That means the opposing power of air. That is called as air resistance. The lighter body will be stored by the air. Right? The feather of a bird. Right? Then that feather will slowly come to the ground. Why? Because the air will try to push it upward. Right? So that's why if there is air resistance, then this might differ. But if there is no air resistance, then everybody will fall at the same time. Everybody faster. If there is no air, but sorry, on the Earth surface, its value is 9.8 meter per second on the Earth. On the moon, it is 1.62 meter per second square. So the question will come, may come. Actually, due to gravity, it's 1.62 meter per second square. Why? What will you write at that time? Actually, due to gravity on the moon is 1.62 meter per second square. Why? Why? What will you write? Ronnie sir?
Yes, sir.
Okay. What is the right? Ronnie sir? Same as that previous one. I भर्खरको क्वेसनलाई मिलाएर त भन्ने हो त्यहाँ अर्थ थियो and there was earth and there was 9.8 meter per second square. Here we have got 1.62 meter per second square. मिलाएर भन Why? Why is the acceleration due to gravity of moon is 1.62 meter per second square? You know, why does that happen? Huh? Okay, Susan, I haven't heard your voice for a long period of time.
Yes, sir.
Okay, tell me the answer, Susan. Susan, why aren't you telling? Rosna? Simple answer, because the velocity of a falling body changes by 1.62 meter per second in every 1 second. Simple answer. Right? Like the previous one, you can change the value only. The velocity will change, right? 1.62 meter per second in every 1 second. Similarly, on the Jupiter, it is 26 meter per second square. On the Jupiter. When the velocity of an object is changing, it is said to be accelerating, right? So whenever the velocity is changing, it is said to be accelerating. That means the velocity is increasing. And acceleration is the speeding of or slowing down of a motion of the body. And we are told if the acceleration is increasing in a certain body, if the velocity is increasing, that means the body is moving fast. It is speeding up on something. If the velocity is increasing, that means the body is moving fast or speeding up. So here we have got the acceleration produced on a freely falling object because of gravitational force of gravity is called as acceleration due to gravity. Simple one. Right? What is the acceleration due to gravity? Definition: the acceleration produced on a freely falling body. Right? Freely falling body with the effect of gravity. Right? Gravity with the effect of gravity with no air resistance. The same thing is written here, right? Acceleration produced on a freely falling body. I have told the same thing on a freely falling body. I have told at last with no air resistance. Air is written at the in the bracket without air resistance. Because of gravitational force, I have told with the effect of gravity. The same thing, right? That's the production of body with the effect of gravity, neglecting air resistance or without air resistance. So the gravity, acceleration to gravity on the surface of the earth is denoted by G, small letter G. I told that don't be confused with small letter G and capital G. They two are different thing. And is expressed in meter per second square. It is meter per second square. Okay, written 2 times. This is the same thing, right? The same thing is written here. You can write meter per second square. Meter per square second, or you can write meter per second per second. At 2 times. It denotes square of second. The value of G is 9.8066 meter per second square. That is 9.8 meter per second square. But on the moon it is 1.62 meter per second square. And if you are using scientific calculator, and at that calculator you have been given the value of small letter G, right? Scientific calculator small letter G value the answer. It is about 9 point. I have forgotten. And you can find the value of that capital G also in calculator. It is given, it is stored there from the beginning. It is very easy for you to find the values. And the acceleration due to gravity at a place is always constant at a certain place. Just for example, I'm staying at this place in Tanau. Again, I'm staying in Tanau. The acceleration due to gravity in Tanau is always constant. It won't change. Right? Just for example, it is 9.77 meter per second square. I have told the value which I have found in the practical lab. Right? We have found the value of G in practical lab in +2. It was about 9.76 or 77 about that. Right? That is constant on that place. Italian scientist Galileo had proved in 1590 that two objects of different mass possess equal acceleration due to gravity while falling towards the earth. Right? He has proved this thing that anything will be the mass. Right? Mass that is chaos. The body will fall at the same time. So duita body ke huncha ekachoti khasana prove gareko थियो. It is done by Galileo. He was an Italian scientist. For this, two objects of different mass were allowed to fall from the top of Leaning Tower of Pisa. We have got the figure in previous page. Look at it. In this tower, he had taken two bodies and he has led two bodies to fall on the ground from the top. And both of them reached on the earth surface at the same time. And different peoples gathered here to see that experiment at that time also. Gather experiment like it done by Galileo. And you can listen to that story in YouTube also. Okay, tomorrow we'll do this coin and feather experiment. Right? Any question for today?